So this is the third video of the acids topic. Again, this is a paper one only topic. And in this video, I'm going to look at the reactions of acids. I'm going to look at how acids react with bases and how acids react with metals. So we'll start with bases. If you have an acid and you react it with a base, you are going to form salt and water. Now you might be wondering what exactly a base is. So I've got a definition below. So bases are substances that react with an acid to form salt and water. So any substance that reacts with an acid to form salt and water can be called a base. So we're going to have a look at some examples. Here I've got an acid, and I know it's an acid because it's literally got the word acid in the name, hydrochloric acid. I react hydrochloric acid with a substance called calcium oxide, and when I carry out this reaction, I form salt and water. So the question is calcium oxide a base? Well, the answer is going to be yes. When it reacts with an acid, it forms salt and water, therefore calcium oxide is a base. If I look at another example, again, I have an acid. It's a different acid this time. I've used sulfuric acid, but again, it's still an acid. And I react this acid with a substance called sodium hydroxide. And when I do, I form salt and water. Is sodium hydroxide a base? The answer again will be yes, because when sodium hydroxide reacts with an acid, it forms salt and water. Therefore, sodium hydroxide is a base. In the next example, I've stuck with sulfuric acid as my acid, and this time I'm reacting with calcium carbonate. And when I react my acid with calcium carbonate, I get a salt, I get water, and I get carbon dioxide. So is calcium carbonate a base? The answer is again yes. Okay, so it does produce carbon dioxide, which is not part of our definition, but it does still produce salt and water. As long as it's producing salt and water, when it reacts with an acid, it is going to be a base. So calcium carbonate also classified as a base. Last one, I've switched to nitric acid this time, but again, it's still an acid, and I'm reacting an acid with copper. And when I do, I form a salt and I form hydrogen. So is copper a base? The answer would be no. Okay, it is forming a salt, but it's not forming water. It's just forming hydrogen. Therefore, copper is not a base. So I can classify calcium oxide, sodium hydroxide, and calcium carbonate as being bases because they all react with acids to form salt and water. But copper is not a base because it reacts with an acid to give me salt and hydrogen. So there are lots of different substances that act as bases, but in general, you can summarize them as being either a metal oxide, a metal hydroxide, or a metal carbonate. So what I mean by that is if you take any metal and you put it in front of the word oxide, you're going to have a base. And you can see our first example, calcium oxide, would be a metal oxide. A metal hydroxide, if you take a metal and put it in front of the word hydroxide, that would be a base. And our second example there would be a metal hydroxide. And then we've also got metal carbonate. So the name of a metal in front of the word carbonate, such as calcium carbonate, that would also be a base. So metal oxides, metal hydroxides, and metal carbonates, they act as bases. They will react with an acid and form salt and water. You can see at the end the copper does not fit into any of these categories. Yes, it's a metal, but it's not followed by the word oxide, hydroxide, or carbonate. So when it reacted with an acid, we saw we did not get salt and water. Instead, we got salt and hydrogen. Now you might be wondering about sodium hydroxide because we came across this in a previous video, and I was saying sodium hydroxide is an alkali, and now I'm saying sodium hydroxide is a base. So what exactly is a base compared to an alkali? Are they different or are they the same thing? If you look here, I've got my definition again for a base. So if a substance reacts with an acid to form salt and water, then I can call that substance a base. Okay, sodium hydroxide does react with an acid to form salt and water. Therefore, I can call sodium hydroxide a base. But when we look at bases, we've got two different types of bases. We've got bases that are insoluble in water, and we've got bases that are soluble in water. So if the base is insoluble in water, if it doesn't dissolve in water, then it is going to be a solid and has the state symbol S. If the base is soluble in water, then it is going to be aqueous and it's got the state symbol AQ. Bases that are soluble in water have a special name, and that name is alkali. So we've come across alkalis before, but they're just bases that are soluble in water. So anything reacting with an acid to form salt and water is a base. If that base is soluble in water, then you can also call it an alkali. If the base does not dissolve in water, then I cannot call it an alkali. So I can call all of them bases, but only the ones that are soluble can I also call them alkalis. And remember, if you've got an alkali, you're also producing OH minus ions, and you've got that pH above 7. Your insoluble bases are not going to be producing OH minus ions, because remember, when we looked at alkalis, they had to dissolve in water in order to produce the OH minus ion. If your base is insoluble and if it does not dissolve in water, then it's not going to produce the OH minus ions. With the pH, you can only get the pH of a solution. You can't get the pH of a solid. So again, I don't have a value for pH of a base. Okay, so alkalis, special name for soluble bases, and I can also say that they have OH minus ions and a pH above 7. I can't say that for an insoluble base because you can't get the pH if it doesn't dissolve, and you can't get OH minus ions if it doesn't dissolve. As I said, whether the base is soluble or insoluble, all bases are going to react with acids and they're going to form salt and water. It doesn't matter if it dissolves in water or not. So if you have an acid and a base, it will react to give you salt and water. When you're writing these equations, it's not enough to just write salt. You need to actually be able to name the salt, and the name of the salt contains 2 words. The first word in the name of your salt comes from the base, and it's going to be the metal from the base. The second word in the name of the salt will depend on your acid. If you use hydrochloric acid as your acid, then the second word of the salt is chloride. If you use sulfuric acid, the second word is sulfate. Nitric acid, the second word is nitrate. So again, the easiest way to do these is just to do some examples. So here I've got hydrochloric acid and I've got sodium hydroxide. So this is my base. It's a metal hydroxide. It's a base and it's reacting with my acid to give me a salt and water. It's not enough to just write salt. I have to name it. So you can see my salt has 2 different words. The first word is the metal in the base. So sodium hydroxide is my base. The metal in my base is sodium, so sodium is the first word in my salt. The second word in my salt comes from the acid. The acid is hydrochloric acid, so it ends in chloride, and then I also form water. If I look at another example, I've got nitric acid, so that's clearly my acid, and lithium hydroxide. So it's a metal hydroxide, so lithium hydroxide, that is my base. The first word in my salt comes from the metal of the base, so that's going to be lithium. The second word in my salt comes from the acid, so it's going to be nitrate. The next example here, so I've written this the other way around, but it doesn't change anything. This is clearly my acid. It's got the word acid in it. Magnesium carbonate, my metal carbonate, that is my base. The first word in my base is the first word, the metal in my base is the first word in my salt, so that's going to be magnesium. Sulfuric acid is going to give me the ending of sulfate, so I've got magnesium sulfate. I've also got water, so I get salt and water. But anytime you've got a carbonate base, you also produce CO2. So I said bases were metal oxides, metal hydroxides, and metal carbonates. If you've got a metal carbonate base, as well as getting salt and water, you'll also get CO2. Carbon dioxide is a gas, so if you carried out this reaction, you would see some fizzing. But a few more examples that we're going to do to together. So I'm just going to move this down a little bit. So lithium hydroxide plus hydrochloric acid. This is clearly my acid. It's got acid in it, which means this one must be my base. The metal from the base is my first word, which is going to be lithium. The second word in my salt comes from the acid. If it's hydrochloric acid, it ends in the word chloride. And then my final product is water. Copper oxide plus nitric acid. Copper oxide is my base. The metal from my base is copper, so that's the first word in my salts. Nitric acid is my acid. If it's nitric acid, it ends in nitrate. And then I also form water. I'll just do one more for you. Sulfuric acid and calcium carbonate, that's my acid, meaning this is my base. The metal from my base is calcium. Sulfuric acid, it's going to end in the word sulfate. I form water, and then because it's a metal carbonate base, I'm also going to form CO2, so carbon dioxide, if I wrote that out in full. Have a go at doing the last two yourself. Press pause, fill it in, and then press play for the answer. Okay, so there are your answers. This is my base. Copper is my metal, so copper is the first word. Hydrochloric acid ends in chloride, so it's copper chloride plus water. And because my base is a carbonate, I also have CO2. The next one, this is my base, potassium hydroxide. The metal is potassium. If it's nitric acid, the second word is nitrate. And again, I've got water. So it doesn't matter if you wrote which way around you write these. As long as you've got all of the correct products, you will get your marks. You will notice that I've included the state symbol next to the bases. Lithium hydroxide is aqueous, so it does dissolve in water. So as well as calling it a base, I could call it an alkali. Copper oxide doesn't dissolve, so I can only call it a base. I can't call it an alkali. Down here, potassium hydroxide, it's aqueous, so I can call it a base, but I can also call it an alkali. Either way, whether it dissolves or doesn't dissolve, it's not going to affect your products in these reactions. You're always going to form a salt and water, and if you've got a carbonate base, you'll get that extra product of carbon dioxide. So these reactions that we've just gone through are called neutralization reactions. When you react an acid and a base, you get a neutralization reaction. And the reason we call them neutralization reaction is because in all of these reactions, you are forming water, which has got a neutral pH. pH of 7 is a neutral pH, and water has that pH of 7. So we call them neutralization reactions because you're producing a neutral product. You are producing water. So anytime you react an acid and a base, it's called a neutralization reaction as you are producing water. And there is a core practical where you are expected to investigate how pH changes during a neutralization reaction. And in the reaction that they've got here, they take calcium hydroxide, it's a metal hydroxide, so it's a base, and they react it with hydrochloric acid, which is an acid, and they form a salt and they form water. So the salt is calcium chloride because they're taking calcium from the base and it ends in chloride from hydrochloric acid, and you're also forming water. And what they want you to do in this experiment is they want you to investigate what happens to the pH of the acid when you add the calcium hydroxide to it. So you start out with a beaker of acids. Remember, acids are always going to be aqueous because they're always dissolved in water. So you're not going to have a solid acid. So you start off with your beaker of an acid, okay? And you're going to want to get the pH of your acid. So you could use a pH meter, and you find out at the start that your pH is, let's say it's 2, okay? It's an acid, so it has to be less than 7. You use your pH meter and you find out. Then what you're going to be doing is you're going to be adding your base. Now let's just assume that it's a solid base. So because it's a solid base, I'm going to have a spoon with a solid base on it, and I'm going to be adding my solid base to my acid. So I add my base to my acid and I give it a stir. And when that happens, the base is going to react with the acid, and you are going to form salt and water. And what you're investigating is how that pH changes as you add the base and you start to form salt and water. Well, we know that water has a pH of 7. So as we keep adding base, you would expect to start forming water. Water has a pH of 7, so we should see that pH increase as we add the base to the acid. So in order to do this accurately, you're going to add a spoonful of base, you're going to stir it, you're going to measure the pH. Then you add another spoonful of base, stir, you measure the pH. Another spoonful, stir, you measure the pH. So what they did here in the experiment was they measured out precise amounts of the base. So they added at the start, let's just say you only had your acid, so it was pH of 2. Then you added a small amount of base and stirred, got the pH again. Another bit, stirred, got the pH. You keep adding more and more and more and more base. And what you should see is that the pH continuously increases because the base reacts with that acid, forms salt and water, which has a neutral pH of 7. In terms of how they ask this in the exam, it is very straightforward. Describe how you would investigate the change in pH when adding calcium hydroxide to hydrochloric acid. So calcium hydroxide is a base. It's a metal oxide, so it's a base. So how is the... To be fair, it doesn't even ask you what's going to happen to the pH. It just wants to know how you would investigate it. So all you need to say is that you measure the pH of the hydrochloric acid at the start. And you're going to do it with a pH meter. It's more accurate than using an indicator because it gives you a precise reading. So you measure the pH of your acid at the start. Then you add your base. You need to do it slowly and you need to stir, and you get a mark on the mark scheme for mentioning stirring. Stirring is going to help it react. After each addition, so each time you add some calcium oxide, you have to get the pH again. Okay, so this answer here is going to get you 3 marks. So you measure the acid at the pH of the acid at the start with a pH meter, so say how you measure it. You add the base slowly with stirring. You have to mention stirring. And then each time you add some calcium oxide, you measure the pH so that you end up with a table that shows the pH slowly increasing over time. We've got one more reaction to look at. So we've looked at acids reacting with bases in neutralization reactions forming salt and water. Now we're going to look at acids reacting with metals, and we will see that they also form a salt, but instead of forming water, they form hydrogen gas. So I have an acid and a metal form salt and hydrogen gas. The name of the salt is going to be exactly the same as what we've just seen. So instead of having a base, I've just got a metal. So it's not followed by the word oxide, hydroxide, or carbonate. It's just a metal by itself. But I take that metal and it's going to form this first word in my salt. Then because it's hydrochloric acid, the second word in my salt is going to be chloride. Because it's a metal and not a base, I'm forming hydrogen as my other product, not water. Next example is similar. I've got a metal with an acid. The salt starts with the metal as the first word. Nitric acid means the second word is nitrate, and I form hydrogen. The next one, I've got a different metal. No, sorry, same metal, magnesium, but a different acid. First word of the salt is magnesium. Second word is sulfate, and then I've got hydrogen gas. So I'm naming these salts in exactly the same way as I was naming when I was reacting the acid with a base. If I were to write, I'm just going to write out an equation here. So I've got hydrochloric acid is HCl and calcium is just Ca. So you can see that you're forming the salt calcium chloride. Now I'm going to write down the formula for calcium chloride. I'm not going to go through how I worked out that formula. I do a separate video on writing and balancing equations. But the formula of calcium chloride is HCl. So what you can see when you're forming the salt is that you have the calcium is in the salt and the chlorine is in the salt. And what you're left with is the hydrogen from the acid. So you're left with H2. That's why hydrogen is your extra product. You don't include it in the salt, so it's left over and you form H2. If I had a base instead, so if I had hydrochloric acid, and instead of having calcium, if I had a base, if I had calcium oxide, because metal oxides are bases, I would form the same salt, so I would form calcium chloride. So I'm using up the calcium and I'm using up the chlorine in my salts. And this time, not only am I left with a hydrogen, but I'm also left with an oxygen, which then combine to give me H2O. So when you have got an acid and a metal, you get the salt and hydrogen because there's no oxygen from that metal that can combine with the hydrogen to give you water. When you've got a base, because your bases are metal oxides, metal hydroxides, metal carbonates, you've always got oxygen in the base. And the oxygen from the base will react with the hydrogen from the acid to give you water. So that's why you get hydrogen with the metal and water with the base, but you always form a salt, and the naming of that salt is going to be exactly the same whether it's hydrogen or whether it's, naming salt is going to be the same whether it's a metal or a base you react with your acid. Final thing to note, when we said in the reactions that produce carbon dioxide, I said you would see fizzing because carbon dioxide is a gas. It's the same here with hydrogen. Hydrogen's a gas, so you're going to see fizzing. If you wanted to confirm that the gas you're producing was hydrogen, your test for hydrogen is to use a lit splint and you will hear a squeaky pop. Okay, I've got some questions here for you, so I want you to press pause, do the questions, and then press play when you're ready to see the answers. Okay, I've got the answers here. The first one, what would you expect to see when copper reacts with sulfuric acid? So you've got a metal reacting with an acid, you form salt and hydrogen gas. Because you are forming hydrogen gas, you will see bubbles. Why do you see fizzing when copper reacts with a nitric acid? Similar to the question above, you see fizzing because you're producing a gas. Specifying that the gas is hydrogen gets you the second mark. How can you prove it's hydrogen? Lit splint, squeaky pop. If you don't mention the lit splint, you don't get the mark for squeaky pop. So if you just write squeaky pop, you actually get 0. You don't even get 1. You can't get the squeaky pop mark without the lit splint mark. Complete the equations for the reactions of acids and bases. So the metal from the base is magnesium. It ends in sulfate because it's sulfuric acid. The metal is iron. It ends in nitrate. The metal is copper. It again ends in nitrate. The metal is calcium, and this time it ends in chloride. You are always forming water, and when you've got a carbonate base, you're also forming carbon dioxide. So acids and bases gives you salt and water. What would you see with the calcium carbonate and the hydrochloric acid? Fizzing, or you can say bubbles, and again you're producing a gas. This time it's carbon dioxide. So why do you see fizzing? Because carbon dioxide gas is produced. So just mentioning a gas is produced gets you a mark, but specifying that it's carbon dioxide gets you your second. Your test for carbon dioxide, you bubble it through lime water and lime water turns milky. So hydrogen is a lit splint, squeaky pop. Carbon dioxide, lime water turns milky. This question 9 is about the practical. So you measure the pH of the acid at the start with a pH meter. You add the copper oxide or whatever it is they tell you to add. You do it slowly with stirring. You have to mention stirring. And then you measure the pH after each addition of copper oxides. You have to say that you don't just take the pH once at the start and once at the end. You're taking the pH every time you add some copper oxide. Why is it better to use a pH meter than an indicator? It's more accurate. It gives you a reading to like 1 or 2 decimal places. With an indicator will just tell you if it's an acid or a base. It won't give you a specific reading for pH. In the next video, we're going to look at 2 other practicals. We're going to look at how you make salts using either a soluble base, so an alkali, or an insoluble base. There's 2 different methods for making salts. One of them is a core practical, so gets asked all the time.